Hello everyone, let's get started. This question is 6 particles situated at the corners of a regular hexagon of side A move at constant speed v. And how is this v? Each particle maintain a direction towards the particle at the next corner. So find the time the particles will take to meet each other. So particles are kept at these corners. The red ring is representing the particle, and you can see the particle at every corner is moving with velocity v towards the next particle, and the same way the next particle is moving with velocity v or speed v, constant speed v, to the next particle, and so on in this hexagon. So how will you get the time when the particles will collapse to each other, will meet each other? I mean, all the particles will meet at one point. Since the speed of each particle is v, so if we get the velocity of approach between one particle and to the next one, then with this velocity of approach, the particle requires to cover a distance a, and from there you can get the time. So this is the concept behind it. Hopefully you are understanding it, because each time the particles direction will keep changing. But heading will always be towards the next particle, and so on. The next one to the next one to the next, and so on. So how to get the velocity of approach? Just extend it. This is a regular hexagon, This is a regular hexagon. So this angle will be 60 degree. So the component of velocity at this corner along this direction will be v cos 60 degree. So velocity of approach between, if we say this corner as A and this corner as B, so velocity of approach between the particles located at corner A and B is we write like this, or speed. Rather you should say speed, because its direction is continuously changing. So VAB is the velocity of approach if we say. Then velocity of A in the direction of B minus velocity of B in the direction of AB. So VA is V, VB component in the direction of AB is V cos 60 degree. So V minus V by 2 cos 60 is half. This will be your V by 2. So VAB, you got velocity of approach between A and B, you got V by 2. With this velocity of approach, how much distance it has to cover? That is A distance. So time you can easily get. Distance is A divided by velocity of approach between AB. To A by V. So this will be your answer. Other way you can think of that all the particles, since it is moving with the same speed and always heading towards the next particle. So all the particles will meet at the center of the hexagon. So this is the center of the hexagon. So you can say that each particle has covered a displacement this much, each particle to meet at point O, that is O if we call the center. And what will be the direction of the component of velocity along this? Since it is a hexagon, again you know that it is, this angle will be 60 degree, and similarly all will be 60, 60, 60, 60. This angle also 60 degree. So this will also be 60 degree. So this triangle OAB will be an equilateral triangle. So OA will be equal to OB. OA will be equal to OB is equal to AB. So we are interested in knowing OA. So OA is equal to AB, means is equal to A. And what will be the component of velocity in the direction of A to O? V cos 60 degree. So from there also you can take out the time. You know that displacement is AO and the component of velocity in this direction is V cos 60 degree. So this will be your time. Put the value, you will get the same thing. So this is another way of finding it. So hopefully you understood the concept. In case any doubt, please do let me know. Thank you.